In lab, you guys were looking at speed and velocity, and we're going to take a little bit of time to define those in your notes. So first, let's start with speed. Speed is something you guys are pretty much aware of. You've heard about it for most of your life. We're always talking about going places and how fast we're doing that. When we're talking about that, we're talking about speed, how far we go, distance traveled, in a certain amount of time. So speed is a rate. It's a comparison of distance to time. And we're used to miles per hour, but in the SI system or metric system, we'll use kilometers per hour or meters per second. But regardless, if you have a speed of 80 kilometers per hour, that means every hour you move a distance of 80 kilometers. If you have a speed of 75 miles per hour, every hour you go 75 miles. So to calculate speed, it's just distance divided by time. And sometimes you'll see me write this like this, shorthand notation. And when you write it like that, it's easy to see how we can solve this equation to solve for distance. So if we know speed and time, we can get distance, because if we multiply both sides of this equation by time, we see that speed times time equals distance. Okay, which is this equation here. So I wasn't just making that up, it's just this equation rewritten. Similarly, you can actually solve for time, because if I take this equation and divide both sides by t, then we can see that if I want to solve this for time, I'll divide both sides by s, and I can see that time is distance divided by speed. Now sometimes I'll put that all together into this little handy device. Whoops, don't want that. Start that over. Where we put speed up here, distance over here, and time over here. And whatever variable you're trying to solve for, you cover up and you do the resulting thing. So if I cover up s, then I have distance times time. If I cover up time, I have speed divided by distance. And if I cover up distance, I have speed divided by time. Okay? So these equations we can use to find speed, distance, or time. Now velocity is actually a little bit different, because velocity includes direction. So remember, distance is how far something is moved. Displacement is how far something is traveled and in what direction. So velocity is a lot like displacement in that it includes a direction. Okay? And we actually get velocity from the slope of a position time graph. It tells us how fast and in what direction the object is moving. Remember, we assign direction with signs, so mathematically we use positive to mean away from the reference point and negative to mean towards the reference point. So we indicate our direction with the signs. Now, let's take a minute to see how that looks. So here I have a position time graph, and I better switch to a different color. So let's go with red. On this position time graph, there's a variety of different things going on. We can see from the time interval 0 seconds to 2 seconds, the object started at the reference point and moved 2 meters away. Then it stood at 2 meters for 2 seconds, and then it moved back towards the reference point. We're going to investigate this a little bit. Okay? So for instance, if I look at this part of my graph, just the first 2 seconds, so from 0 to 2 seconds, and I want to know about its velocity, that means I want to know displacement, I want to know time. And I can look and I can get displacement. Remember, displacement, which is change in position, which I'll write like this, that's delta x, is final position minus initial position. That would be 2 minus 0, which equals 2 meters. So in the first 2 seconds, the time interval, it moved 2 meters, which means the velocity is the 2 meters divided by the 2 seconds, which is 1 meter per second. But if you look at what I just did, I took the change in position, which is plotted over here, position, and that's this far, this is rise, divided it by the change in time, which is this distance here. This is run. So this velocity that I just calculated is really slope, like we mentioned before. So velocity equals slope. Now some of you might be aware that the equation of a line, so if I wanted the equation of this line, I can give that by y equals mx plus b, where y is generally considered the vertical axis, x is considered the horizontal axis, m is slope, and b is the y-intercept. So if I take a look at that, let me erase this stuff off here. I'm going to draw a separate line on here, and we're going to use this equation to actually figure out what's going on. So let's say I started here, and we're going to go through these points. Okay? So I'm going to connect up this. So this is a second object moving, and I want to know its velocity. I want to know everything there is to know about it. Well, if I look at this, the equation of this line, b, is the y-intercept. It tells me where I started. Okay? And so that's actually my initial position. That's my position at the beginning of the interval. And so I know my initial position is actually 1 meter. Now, m is actually the slope, but the slope is velocity. Okay? So I'm going to rewrite b as initial position. I'm going to rewrite m as velocity. Now the x-axis is actually showing me time, so I'm going to replace x with time, and the y value is actually position. Okay? Or in this case, the final position. So x, I'm just going to use that. So x equals velocity times time plus initial position. This equation is actually what y equals mx plus b means in terms of motion. It means, where are you, given that you're going this fast for this long if you started here. Okay, so for this equation, the slope of this thing, rise is 1, run is 2, so this equation actually has a velocity of 1 divided by 2, or 0.5 meters per second. So I can actually say my final position is given by 0.5 times time plus 1, since I started 1 meter in front of the detector. So in algebra, when you learn y equals mx plus b, we use that in science to actually describe the position of an object at any point in time. Now, let's take a look at a couple questions I'm going to ask you on the worksheet, just so you are familiar with how I want these done, so you don't mess up, and also so you know how to work these problems. Okay? So, a person drives 350 kilometers in 2.8 hours. What is the average speed of the car? Whenever you're doing a problem, remember, you have to show work. It is imperative that you show work. If you don't show it, you're not getting credit. So when you read a problem, the very first thing you need to do is you need to pull out your information. Okay, this right here, 350 kilometers, that's a distance. So over here I'm going to write distance equals 350 kilometers. What is its average speed? Oh, nope, we got another piece of information. In 2.8 hours. So I just got a time. T equals 2.8 hours. This is part of your work. If you don't show me what information is given, you don't know what to do with it. The next part of your work is to figure out what we're trying to get and how to get there. We want speed. So we need the equation that relates speed, distance, and time. Well, by definition, speed is distance divided by time. So all we have to do is now that we have our equation, is put those numbers in. So I have 350 divided by 2.8. Now for this part, use a calculator. I don't need to see a long division. I want to see that you can set up the problem. And this is 125 kilometers per hour, which seems really fast, but a kilometer is shorter than a mile. This turns out to be about the same as 75 miles per hour. So that's a reasonable answer. Okay. Another question, a person walks away from a motion detector at 0.75 meters per second for 5 seconds. How far did the person walk? This time we're given the speed, and actually we're given a direction as well. So I'm going to say velocity. Velocity is 0.75 meters per second. Okay. We're given a time. T equals 5 seconds. And now I need to find how far. That's a displacement, or a d. How far did we go? Well, I know speed equals distance time, but I also know displacement is speed, or velocity in this case, times time. So I have 0.75 times 5. 0.75 times 5 is 3.75. Now, what's my unit here? Well, let's take a look. I have 0.75 meters per second times 5 seconds. This second cancels that second, and I'm left with meters, which is good because I was going for a distance, and meters measure distance. Okay? Now, another thing you'll have to do is interpret graphs. So here's a graph, and again, I better grab a different color, so go back to red. Okay. And I want to know everything there is to know about this graph. that means we're going to divide it up into its distinct time intervals. Now, an interval in time lasts however long we need it. We divide up a graph based on when the motions change. So the motions on this graph change at 0 to 3, we have a constant motion, but at 3 it changes. 3 to 5 we have a constant motion. 5 to 8 we have a constant motion. So I'm going to go ahead and I'm going to discuss the first interval. Okay, so the first time interval is 0 to 3 seconds. I want to know its displacement. That's how far it changed. So change in position is delta x. Well, that means I want to know how far it is from where it started. So it started at 5, it ended at 2. Now displacement is always final position minus initial position. So I have 2 minus 5, which is 3 meters. So this thing moved 3 meters in the first time interval, except that's negative because it's moving towards the detector. If I want to know the velocity, then velocity is displacement divided by time. Now the time for this interval is 3 seconds because it lasted 3 seconds. So I'm going to take negative 3 divided by 3, and I get negative 1 meter per second, which tells me my direction is back towards the origin, back towards the reference point. So negative 1 meters per second toward the reference point. I can do the same thing for the next interval, 3 to 5 seconds. I want to know the change in position. Well, this time it's 3 minus 2, final minus initial, and 3 minus 2 is equal to 1 meter. So it moved 1 meter. Velocity is displacement divided by time. That's 1 meter divided by, now be careful here, the time is from 3 to 5, which is 2 seconds. So 1 meter per 2 seconds, which is 0.5 meters per second. And this is positive, which means we're moving away from, our position is getting bigger, it's increasing away from the reference point. And then finally, our last time interval, 5 to 8, the displacement is 0. Right? It started at 3 meters and it never changed, which means my velocity is also 0 meters per second, and there is no direction because it is at rest.